Hello, this is Mr. Moss here with section 2.4 of chapter 2. We're going to be talking about some proofs now that is involved in geometry quite a bit. But before we get into the geometry part of it, we're going to talk about the mathematical part of it because of something that we've done and know about in the past. So when you guys have solved a problem by either adding or subtracting, multiplying or dividing, we've actually used properties and reasons or statements as to how we were doing that. So, when we find a math problem, we usually have to do multiple steps. And when you do multiple steps, that's like doing a proof because you come up with a final answer. So that's the same thing in geometry, but now we're going to use geometric properties that are called theorems and postulates and axioms. But this first section of this thing is going to be talking about mathematical ones. So first one, and you guys have had this and talked about it, but I don't know if you remember it as much, but addition property of equality. Basically what it means is if you take something and you have something along the lines of, let's just go up here general, let's go A equals B, just so to say, okay? So if those two equal each other, all we do, and when we do something, and we've talked about it like being a balance, or what do we want to call it? You want to balance each side. So if you do something to one side, you have to do it to the other side. So when we talk about the addition property of equality, it means if I'm going to take something like A and I add C to it, that means I have to do the exact same thing on the other side. Does that make sense? So we balance it out. So if I were to have something like this, let's do a mathematical one. Let's go 5. We'll go, and I know this is not true, but we're just going to show it just for purposes, and we'll put a 3 there, okay? So what I want to do is if I want to take and we want to do the C version of it, we'd go 5, and if I want to add 2 to it, that means I would have to add 2 to it to the other side. Like I said, I know it doesn't mathematically work out, but the concept is, and we're going to be using variables, so if I did something like this, I did it 5x, and we did 5x, we would sit there and do that too, and make it all work. So does that make sense there? So if we add something on one side, we have to add the same thing on the other side, okay? It's like a basic algebra problem that we do. And so if we're solving for, maybe let's go x minus 2 equals 3. In order to be able to solve for x, what did we do? We added 2 to both sides to get x equals 5. Does that make sense? So what we did, again, we used the addition property of equality by adding things to both sides. So you can kind of understand as we go through these what's going to happen again. So let's go ahead and do this one here. So if we do subtraction, I'm going to show the same concept. I'll do this one. A equals B here again. And then if I need to, if I have to subtract something from the left side, I have to do the exact same thing on the right side. So if we were to use an algebra problem here, we would do something along the lines like this. So we would go, let's do the same thing, 5x. Now we'll go plus 2 equals 3. So in order to be able to do that, we would have to do what? Let's write up here again, I apologize. 5x plus 2 equals 3. In order to be able to get that, we would have to subtract it from both sides. So notice I subtract the same thing, giving us an answer of 5x equals 1, and then we'd solve it for that part, okay? Same thing for multiplication. So if I sit there and have A again equals B, and now I'm going to multiply, so I sit there and say A times C equals B times C. So a scenario on that one would be something along the lines of, let's go x over 2 equals 4. Just random. So in order to be able to solve for x, I would have to multiply this side by 2 and this side by 2, again balancing it out. So if I did it to one side, I have to do the other, so then these 2's would cancel out, and I'd get an answer of x equals 8. Okay? Division problem, same scenario, and this one's a little more common than we know as far as multiplication is concerned. Again, a equals b. If I have a and I divide by c, or I use the division, or I like to use the fraction bars, I do the same thing to the other side. So we're dividing both sides by that. So we have something like this, 3x equals 9. Okay, in order to be able to solve for this problem, what are we doing? We're dividing both sides by 3, giving me x equals 3, because we cancel out, or we simplify the fraction there to do that. Okay, now, these other properties, and I remember as a teenager, I struggled with these a lot too, as far as remembering which one was which and how it worked. Okay, so let's look at some of these properties here. Let me get my notes here for this stuff. So reflexive property, basically what it means is it's like looking into a mirror. All you have to do is A equals A. Whatever's on this side has to equal the other thing on the other side. Okay? Now, symmetric property is something a little bit different, where we sit there and say A equals B, and then all we do is switch these two spots, and we sit there and go B equals A. Okay? So all we did is so no matter what side it's on, A to B, and then we switch it B to A, it is exactly the same on both sides. Now, transitive property, we talked about this a little bit yesterday in class, where you have to have 3 things. Okay, I'm just going to write that here as a thing. So we have this. So if we say A is equal to B, then B is equal to C. See, here we go. And then because B is common between the A and the C, then we get to do that. We know that A is going to be equal to C. Okay? All right. Substitution property. Here we go. Substitution property. We're going here of equality. All we're doing is replacing something with something else of equal value. So if we had a general math problem like 3x equals, I don't know, 3x equals 12. Let's just do that. Okay, and we know, and they say, okay, can x equal 4? So all we do is we take the 4 and we plug it in for the x, and we go 3 times 4 equals 12. Okay, and 3 times 4 is 12 equals 12, so this statement is true. So, I mean, it doesn't necessarily mean it has to, so we could be solving a problem that looks like this, where we have only something like this, where we sit there and say 3x plus 4, okay, and we have to solve for it. And if we take maybe x equals 2, we would plug in 3, replace the x with the 2, plus 4, and then plus 4, that's a word for, so we get 6 plus 4, and that equals 10. So all we're doing is replacing something for something of equal value. Now, the distributive property is something where we take, and it's like, I think about it like a cookie truck or somebody, or a bread man or whatever, that goes to each store and drops off their loaves of bread at each one of the stores so they can do that. Okay. The distributive property meaning if we take A and we have something like this and we go B plus C is how we write that. Remember, we got to take in, because this is out here, we're using the multiplication, and we have to, and I like to draw arrows, and I need to multiply it to each one of those. So whatever, how many items or stops or stores that a bread man has to go to, we have to take in and multiply that by that. So we would get A times B would be AB, and then A times C would be AC. Again, all we're doing is distributing in a scenario like that. So if we did something like this, 3 times x minus 1, okay, I know we've done this before. We distribute, and some people like to go 3 times x, okay, like this, and then 3 times negative 1, however it works for you, but I like to do the arrow things, and then we get an answer of 3x minus 3 as our final answer. All right, last one of these ones for mathematically, we have simplifying, or simplifying meaning combining like terms. So if you have a general problem, I'm just going to go 3 plus 4. These are like terms because they are both constant numbers. So all we do is just combine them and we get 7. Okay, we have another example where we take 3x plus 4x. Okay, these are common or like terms because they both have a number in them and they both have an x in them. So if they both have the same thing, we can say that we have 7x. Now, something that does not combine, so we have 3x plus 4y. Okay, this has an x in it, this has a y in it, so they are not the same. So can we combine these? The answer is no. So this is our simplified version. Okay, any questions on that part? All right, let's look at some examples now. Here we have a scenario, and I'm not sure if I'm going to get through all these before the 15 minutes comes up here, but we're going to try. And here we go. So prove that negative 5x plus 4 equals 70, then x equals negative 18, justify each step. So what we want to do is we want to rewrite the thing. So what we like to do is I like to draw a 2-column proof, and we have these are our statements and our reasons. Okay, so here's a scenario. So we want to write down the first one, which is negative 5x plus 4 equals 70. So what we want to do is now there's a lot of different ways we can go about doing this. What we're going to do, we could plug in negative 18 in if you're here and find out that. So when we do that, so we sit there and take negative 18 and plug it in here, we are going to use, and we got to tell what proper. So we always write this, the one we always have, we're going to write it as given. Okay, so now what we can do is we're going to take negative 5, and I'm going to get a different color pen here. Let's go red, and I'm going to substitute in negative 18. Okay, that pen didn't look too well. Plus 4 equals 70. So now what do we do next? I'm going to underline it. Okay, but over here we want to write substitution. Okay, because that's the reason. We want to know what the reason we did. Okay, so now what is negative 8 plus 4? So I'm going to go ahead and take negative 5 out here. Negative 18 plus 4 is going to give me negative 14. I'm going to go 70. So what did I do here? I simplified. Okay, is my reason because I took and combined like terms. Now what's the next thing I'm going to do? Is negative 5 times negative 14. So 5 times 14, it shows that now a negative times a negative is going to be a positive, okay, and equals 70. So what did I use? Okay, so is this a true statement? Yes, it is. So we're done for that part. Okay. All right. So your turn on this. I want you to do the same thing. But I mean, there's another way you could have done it. I mean, let me explain that real quick. I have about 30 seconds. That I could have done on this first part, done the distributive property first. Okay, and then wrote that in by taking negative 5 times x and 4. And then I could have done addition, subtraction. Maybe I'll do that on the next part. All right, so we're done for this first segment.